So, problem 14. A proposed mechanism for the reaction of carbon dioxide with hydroxide ion in aqueous solution is carbon dioxide plus hydroxide ion, which forms bicarbonate ion. That is for the first step, and that is a slow one. And then we have the bicarbonate. So let's write that one. Okay, for number 2 is we have bicarbonate C3 minus. As you can see, class, the the product in the first step is used as a reactant for the second step, plus OH minus. This forms CO3 2 minus and water. So this one is a fast reaction. Okay. So this one, okay, so let's write the overall reaction. Okay. As you can see, class, the bicarbonate ion is a product in the first reaction and is a reactant on the second reaction. And as you can see in the product, bicarbonate is not found. Okay, because the bicarbonate is consumed. The bicarbonate is consumed, and hence the bicarbonate here is the intermediate reaction. Okay, so now let's write the overall first. Okay, now let's find the things or the substances that we can cancel. Class, we can cancel if the other substance is on the left side and the other is on the right side. Okay, on the left side and on the right side. And also, if the substance is not on the same reaction, like here, HCO3 is on the right side. Okay, good that it's on the right side. Number two, is it on the same reaction? Number two, is it on the same reaction? No, it's in the slow reaction. Okay, so they are not the same. Now we can cancel the intermediate reaction. That is what we call the intermediate reaction. Okay, and then nothing more. So this one, the OH, the hydroxide ion, we cannot cancel because it's on the same side. Okay, so we have CO2 plus, okay, how many OH ion? We have two. So two OH ions, and then we have, okay, what's left here? This can form CO3 2 minus plus the water. Okay, so this is our overall. Okay, let me box this one. Okay, so this is our overall reaction equation. Okay, so this is letter A. Now we are asked of letter B. Identify the intermediate or intermediates, if any. Okay, so letter B, the intermediate is, yes, the intermediate is the substance that was formed and used up in a reaction. So that is our bicarbonate. Okay, now number letter C. What are the molecularity and the rate law for each step? Okay, so let's write first the rate law. Okay, for each step, we have two steps here. Okay, so step one, the rate is rate is K constant times we have CO2 OH minus. Okay, that's for the first step. Now for the second step, let's write 2 here and 1 here. K constant times HCO3 minus times OH minus. Okay, so that's the rate. Now what is the molecularity? Okay, molecularity. Okay, so the molecularity of each step is equal to the number of reactant. Okay, now example, if we have a reaction A and then we have the product. Okay, so what is the molecularity of this reaction? We have how many number of reactants? We only have one number. So molecularity. So this one is unimolecular. And then what if we have 2A? Then we have the product. Then that is how many number of reactants? We have two numbers of reactant, but we only have same reactant, one kind of reactant, but still, since molecularity is equal to the number of reactants, so we have two here. So that is what we call by molecular. Okay. So we just add prefixes. And then if we have A plus B, then we have the product. Okay, so two number of reactants. So we have bimolecular again. And then if we have this one product. So that is thermolecular. Okay? Now, I hope that it's clear. So let's go. Now in this first reaction, what is the molecularity? Okay, it is bimolecular. Bimolecular. Cular. Okay, I hope that you can read it. I write it na lang. Bimolecular. And then we have in reaction 2, we also have two, two reactants. So we have bimolecular. Okay. Now letter D. Yeah, so let's go to letter D. Okay. Is the mechanism consistent with the actual rate law, which is K K constant times the carbon dioxide and then the hydroxide ion? Is it consistent? Okay. What is the overall rate law? Here in letter D, okay, let's write a rate law from the overall reaction. Okay, so let's write that one. Rate is equal to K times CO2 times OH ion. Okay. Now, is that the same to the question letter D? Letter D? Yeah. So our answer in letter D is yes. It is consistent based on the overall reaction. Okay. So that's it. Okay. That is number 12.